What is the value of 2 to the power of 0 plus 20 to the power of 0 plus 201 to the power of 0 and 2016 to the power of 0? That's 1, that's 1, that's 1, and that's 1, since anything to the power of 0 is 1. So the answer for this is 4. Zelchko traveled at 30 kilometers an hour for 20 minutes and then traveled at 20 kilometers an hour for 30 minutes. How far did he travel in kilometers? Speed equals distance over time, and therefore distance is speed times time. So the first distance would be his speed, which is 30 kilometers an hour, times, well, it's 20 minutes, but we're going to convert that to hours, so it's a 1/3 hour. So 30 times 1/3 is 10, and that's 10 kilometers. The second distance, d2, is when he's traveling at 20 kilometers an hour, and that is for 30 minutes, which is half an hour. So 20 times a half is 10 again. So the total is d1, obviously, plus d2, which is 10 plus 10, and that is 20 kilometers that he travels in total. The operation symbol is defined as a symbol b is a to the power of b minus b to the power of a. What is the value of 2 symbol 5? So let's do 2 symbol 5 first. According to this definition, it would be 2 to the power of 5 minus 5 to the power of 2, and that's 32 minus 25, which is 7. And then therefore that would be 2 symbol 7, since this guy we figured out is 7. 2 symbol 7 would be 2 to the power of 7 minus 7 to the power of 2, and that's 128 minus 49, and that is 79. Yeah. Two fair dice are tossed, and the numbers shown on the top face of each are added together. What is the probability that the resulting sum is less than 10? Less than 10, probably a lot. So what I'm going to do is I'm going to calculate the probability of less than 10 by calculating 1 minus the probability of the others. 1 minus the probability of 10, 11, or 12. I think that would be probably a little bit faster. Okay, so when you roll 2 dice, you have 6 choices for the first dice and 6 choices for the second dice. So there's 36 possibilities, right? So we've got to figure out, of the 36 possibilities, how many would end up with a 10, 11, or 12 as the sum. Okay, well, 6, 6, 6, 5, 6, 4, 6, 3, 6, 2, 6, 1. Of these, this is 12, this is 11, this is 10. Yeah. And then when you have 5, 5, 6, 5, 5, 5, 4, 5, 3, 5, 2, and 5, 1, this is 11, this is 10. And then with 4, 4, 6, 4, 5, 4, 4, 4, 3, 4, 2, and 4, 1, and that's 10. So these are the only ones, 1, 2, 3, 4, 5, 6, that are this category. So that basically means that 1 minus 6 over 36, because the total is 36. And that's 1 minus 1 over 6, and that's 5 over 6. So 5 over 6 is the probability of getting a sum of less than 10. A palindrome is a positive integer whose digits are the same when read forwards or backwards. For example, 25352 is a 5-digit palindrome. What is the largest 5-digit palindrome that is a multiple of 15? All right, so we got 5 digits, and the largest number, regardless of whether it's a multiple of 15, is 99999, right? But that's not a multiple of 15. Because if you divide it by 15, it doesn't give you an integer. It gives you 6666.6, I think. Okay, so what we need is a number that's multiple of 15. That's the key to this question here. Okay, so if I just took that 6666 and multiplied by 15, I get 99990. this is a multiple of 15. And then if I keep subtracting 15, I will get 999, what do I get, 75. And then if I subtract 15 again, I get 60, and so on, right? If I subtract 15 again, I get 45. And if I subtract 15 again, I get 30. You guys get the point. So one thing you'll quickly notice with these is that the units digit is always either a 0 or a 5. So that means that any multiple of 15, this guy will be either a 5 or a 0. Now, if it's a 0, then this has to be a 0 in order for it to be a palindrome, right? But then that would no longer be a 5-digit number. If the first digit is 0, then at most it would be 4-digit. So the only possibility is that that's a 5. So that means that this guy has to be 5, and therefore that's a 5. And then now we have to figure out what goes in the middle. And then that shouldn't be too hard. Just take out your calculator, and what you can do is figure out the closest multiple of 15 to 60,000, right? Which I think 60,000 is a multiple of 15. I'm pretty sure about that. And then just keep subtracting 15 on your calculator. And then eventually, actually very quickly, not even that much time, you'll get to 989 as the 3 digits in the middle. And I think that's probably the best way of doing this. So there you go. This is the answer. On a particular street in Waterloo, there are exactly 14 houses, each numbered with an integer between 500 and 599 inclusive. There are 14 house numbers, form an arithmetic sequence in which the 7 terms are even and 7 terms are odd. One of the houses is numbered 555, and none of the remaining 13 numbers has 2 equal digits. What is the smallest of the 14 house numbers? So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then if it's an arithmetic sequence, it would be a plus D, a plus 2D, and so on, a plus 3D, all the way 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this would be a plus 13D. Okay, I'm just trying to set this up here. Let's see where we get here. I'm not entirely sure. Let's see here. They give me that one of the houses is 555. Now, I don't know which one. So one of them is 555. It would be nice if they told me which one, but they didn't. And then there's obviously going to be a D. As you can see, it's a plus D, a plus 2D. But this is a very interesting point that they gave me, that 7 are odd, 7 are even. So that basically means that the D has to be odd. Now, that's the only way for the parity to change. For parity to change from even to odd. Because, for example, if D is, well, let's see here. If 1 is an odd number. If D was odd, then the next one will be 556, which is even. And the next one will be 557, which is odd. But if D was even, like 2, 555 plus 2 is 557, which is odd. Then plus 2, 559, which is odd again. The parity wouldn't change. So D has to be odd. So it has to be either 1 or 3 or 5 or 7 or 9. You guys get the point. Okay, let's move this up a bit. And then, another piece of information they gave me, I almost skipped it, is that none of the other 13 numbers have 2 equal digits. None of the other numbers have 2 equal digits. So this obviously has 3 equal digits. So that's very interesting. So let's see here. Let's figure out terms before and after the 555. And let's see if that helps at all to narrow things down. Well, first of all, how long do I keep going here? D is, this is the largest, right? And what are the numbers going up to? They gave me a range here. 599. So that means that, let's put it on the side here. That means A plus 13D, the largest one, has to be less than or equal to 599. And the smallest term, A, the smallest it could be was 500. So even if it's the smallest, I'm just trying to get some parameters here. That means that 13D would be less than or equal to 99, and therefore D would be less than or equal to 99 divided by 13 is about 7 point something, 7.6. And since these house numbers are all integers, D has to be an integer, so the most it can be is 7. So 7, 5, 3, and 1 are the only possibilities, so the 9 we don't even have to check. So that's good. That narrows things down a lot. And otherwise, I'd have to keep going here. Okay, let's do it. So terms before and after 555. Need to put that in, right? Okay, so if D is 1, it would be 554 for the term before and 556 for the term after. Now this fails because this rule right here that the numbers cannot have two equal digits, and obviously both of these numbers have two equal digits, so that fails. So let's see. Does it pass? Yes or no? And the answer is no, it doesn't pass. Okay, let's do the 3. It would be 552 and 558. This fails that two equal digits criteria. 5 would be 550 and 560. This also fails. 7 would be 548 and 562. Now this one so far is okay, right? Because these don't have two equal digits, but we have to see if all of them. So let's just go with this guy right now. That's the only one that sort of works so far. So we'd have 555, 548, and 562, and then we got to fill in all the other ones. So 569, 576, 583, 590, and 597. That's about as high as I can go. And then let me go in the other direction here. 541. I'm just subtracting the difference, which is 7. And then 534, 527, 520, 513, and 506. First of all, these 14? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, they are. And what's the question asking? What is the smallest of the 14? Okay. The smallest would be 506. And yeah, that completes the question. Point Q has coordinates a plus 1 and 4a plus 1 for some a greater than 1, and lies on the line with equation y is equal to ax plus 3. If O is the origin, determine the coordinates of the points P and R so that OPQR is a square with diagonal OQ. Well, the first thing I need to do is somehow draw this so that it actually looks like what they're describing. Okay, so let me think about how to draw this here. It's got to be a square, right? So something like this. Okay, that's a pretty decent square. Not the greatest square, but. And then now I'm going to have to draw a diagonal. There we go. That diagonal. And one more diagonal. And I think that should be sufficient. Just this guy right there. Okay. All right. So that's pretty decent. Not perfect, but it's okay. Let's label this. That's the origin, 0, 0. We call it O. This is P, R, Q. And Q is given as A plus 1 and 4A plus 1. And I think that's it. Anything else they gave me? Oh, they gave me the equation of this line. This line is y is equal to ax plus 3. All right, so y is equal to ax plus 3. And that point is on, Q is on that line, so it satisfies that equation. So when x is a plus 1, y is 4a plus 1, 4a plus 1, a squared plus a plus 3. All right, this should be, put everything on one side. A squared minus 3a plus 2, 0. Yeah, this factors very nicely. 2, 1, minus, minus. So a is either 1 or 2. But they told me a is greater than 1, so that means a is 2. Okay, that's nice. That's a good result. So that means that the q is 3 and 9. So there we go. That's pretty good progress so far. All right, so where do I go from here? What am I trying to figure out in this question anyways? Determine the coordinates of the points P and R. Okay, basically we're trying to figure out the other two. We figured out 2. There's got to be, is there some simple way, or do I have to go through this whole big long comparison of lengths and all that? Well, because I was thinking like, like going down a few units and going right a few units with similar triangles, but not really sure how to do that since... all right, let me just do it the long way. I don't think it's the long way, but whatever. This point M in the middle is very easy to calculate. That's just the midpoint of Q and O. So that's going to be 3 plus 0 over 2, and then 9 plus 0 over 2, which is obviously 3 over 2 and 9 over 2. So that's the coordinates of M. So that's pretty quick. And then the slope of OM, that's just rise over run. So that's just going to be 9 over 2 over 3 over 2, and that's going to be 9 over 3, which is 3. And therefore the slope of PM or PR, that's the negative reciprocal of that, which is negative 1 over 3. You guys remember negative reciprocals, right? Negative reciprocal. Okay, so now that I think will help me figure out the equation of PR. So this line right here. So the equation of PR, let's move this up a little bit. Well, like any line, it's y equals mx plus b. The m we just figured out was negative 1 over 3. And then we can substitute in m, since m is on that line, PR, and m was this guy right here. So 9 over 2 is equal to 1 over 3 times 3 over 2 plus b. And then b is 9 over 2 and then plus a half. So b would be 10? Oh, b would be 5. So that means this equation is y is equal to minus 1/3 x plus 5. Okay, that's a pretty good result. And now I think we might be in for the grand finale here. Now, to get the coordinates, we have to compare lengths. So, for example, O to Q, that diagonal is going to be the same as P to R. So O to Q is the same as P to R, right? Those are the diagonals of a square. Now O to Q, that we can figure that out pretty quickly. That's just going to be 3, using the distance formula, 3 minus 0 squared, 9 minus 0 squared under the square root sign. So that's what, 9 plus 81. So that's root 90. Okay, so that means this is root 90. Okay, I got it. So I think we should be able to do this now. I'm going to have to label something, though. I need some letters. R is going to be, let's call it T, and since it satisfies that equation, the Y would be minus T over 3 plus 5, right? Yeah. Okay, so that means that using the distance formula, I'm going to use MR. Yeah, MR would be equal to MQ, and that's going to be half of this guy. So that would be root 90 over 2. Yeah, because I've got M, right? So might as well use it. All right, I think we can do this here. M to R, would be, well, m is right here. Don't forget that. So that would be t minus 3 over 2 squared plus minus t over 3 plus 5 minus 9 over 2 all squared, all under the square root sign, and that's going to be equal to root 90 over 2. All right, so as long as I don't mess up this algebra, I should be able to get the value of t. Okay, so let's square both sides first of all. That's going to give me 3. That's just going to get the, what's it called, square root sign of this disappear. And I think this I can do that algebra a little bit. And that's going to be 90 over 4, I believe. Yeah. Okay, let's make sure we do this properly. T squared minus 3t plus 9 over 4 plus t squared over 9 minus t over 3 plus a quarter. And let's just put everything on one side, bring over that 90 over 4. All right, so let's collect like terms. That plus that is going to be 10t squared over 9. This plus this minus 10t over 3. And then that plus that minus that is going to be minus 20. Let's multiply through by 9. 10t squared minus 30t minus 180 equals 0. Let's divide through by 10. D squared minus 3t minus 18. And this will factor very nicely, thankfully. And t 3, 6 minus plus, I believe. Yeah, so that means t is equal to 6 or negative 3. And therefore, this would be, let's keep it in the same screen here. If it's 6, it would be 6 and minus 3. And if t is minus 3, it would be minus 3 and 6. So looking at the graph, I think my r is this guy. Hold on, let me think about this for a second. Yeah, the p obviously is this guy, and the r is this guy. And perhaps the 6 minus 3, though. I think maybe the diagram isn't drawn to scale. Yeah. Wait, hold on. 1 second here. I think I calculated this wrong. If it's 6, then it would be 3. Sorry, this is plus 3. Little things like that kind of mess you up. Yeah, so it is, the diagram is drawn properly, actually. So you get 6, 3, which makes perfect sense to be r. And then we have minus 3, 6, which makes perfect sense to be p. Okay, there we go. We got the coordinates. Claudine has p packages containing 19 candies each. If Claudine divides all of her candies equally among 7 friends, there are 4 candies left over. If Claudine divides all of her candies equally among 11 friends, there is 1 candy left over. What is the minimum possible value of p? Well, 19p would be the total number of candies, right? P packages, and each has 19. And then they're saying that if you divide it by 7 friends, each, there's going to be 4 candies left over. What that means is that there's going to be some integer, let's just call it a, and you're going to have a remainder of 4. And then if you take the 19p and divide it by 11 friends, you're again going to get some integer, let's call it b, and this time a remainder of 1. So I'm not sure how that helps. But with this, we can come up with the algebra. 19p basically would be 7a plus 4. That's the algebra that we could get from this guy. And then from this one, we would get the 19p would be 11b plus 1. Yeah. And then, of course, this would be equal to that, right? 7a plus 4 would be equal to 11b plus 1. Okay, so what do I do here? Do I do trial and error? But something tells me that the value for P and therefore the values for A and B are going to be very large. So I would have to go through a lot of choices. Like if I made a table and went through A's and B's to try to get integer solutions for that, it would take me forever. So I've got to find a little quicker way. So a little bit of fancy algebra. If you take the 19p, right, and we add 10, and then we would have to add 10 to that side, it would become 7a plus 14, and that would be factorable to be 7 times a plus 2. And if you do the exact same thing over here, and you take 19p and add 10 to this guy, this becomes 11b plus 11, right, if you add 10 to there, and that is factorable by 11, it becomes b plus 1. So that basically means that 19p plus 10 is a multiple of 7 right here and a multiple of 11. And therefore, it's a multiple of 77, right? If it's a multiple of 7 and a multiple of 11, it'd be a multiple of 77. So then we can conclude that 19p is 10 less, just 19p is 10 less than a multiple of 77. Yeah, I'm pretty sure that's the way you would go about this. So let's write down multiples of 77 and then subtract 10 to figure out possible values for 19p. So 19p, so we're going to write down multiples of 77, but then subtract 10. So for example, 77 minus 10, the first one is 67, and then 77 times 2, I believe, is 154. Subtract 10 would be 144, and then so on. So 221, 298, 375, 452, 529, 606, 683, 760, and so on. But here's the thing. This is all correct, all these numbers, but it's 19p, so the only one that is for sure correct to also match the fact that it's a multiple of 19 is that a number has to be a multiple of 19. And so far, the only one that's a multiple of 19 is this guy. That's the first multiple of 19. So that means that 19p is 760, and therefore p is 40. And the reason we're choosing that guy is because I think they wanted the minimum possible value. Because if there's going to be more, you can keep going here, and you're going to eventually find another value that's a multiple of 19, but they want the minimum one. And that's how we arrive at the p equals 40. In the diagram, A, B, C, D, H, E, F, G is a truncated square-based pyramid. In particular, ABCD is a square with side length 7. EFGH is a square with side length 1. AE is equal to BF is equal to C. G is equal to DH. Each of the 4 trapezoidal faces is partially shaded. On each face, only the region that is below both diagonals is unshaded. If the height of the truncated pyramid is 4, what is the total shaded area? Well, they've given me a diagram, so I'll just label that. I'm certainly not going to try to attempt to draw it again. So that guy is 1, that EF, and they're all 1s, right? 1, 1, like that. And then AB is 7, right? These are all 7s? Yeah. Okay, anything else? The height is 4, but I'm not going to label that because that's the 3D. I'm just going to write height equals 4. And that's sort of the top to bottom height of that particular 3D shape. Okay, so what I'm going to do is I'm going to just look at one face, like sort of head on, it's a little bit easier. And let's just concentrate on EFAB. Basically the same face. I just wanted to draw it again, otherwise the diagram is going to get messy. And then, oh boy, I've got to draw in these diagonals here. So there's one diagonal, and then there's another one here. Okay, that's not so bad. Okay, and then we have to do some labeling here. top to bottom, I'm going to call H. Now be careful, it's not this H. Don't get confused. This is just so the because it's on a slant, right? So it's not going to be 4. Just this is different. So don't get confused. This H is different. I actually don't know what that H is equal to, but my guess is it's greater than 4. Since it's on a slant, it would be a little bit longer. And then what do we need to label here? We're going to need to label, let me think about this here. Probably this distance, this distance here, that little distance there, that black line that I just drew, that height, and then one more would be this distance. That okay, I think that's sufficient. So the red one I'll call H2, and the black one I will call H1. So I'll just write H1 here. Okay, so it's a trapezoid, right? Yeah, so just use a trapezoid formula. That's going to be, this EF is 1, AB is 7, so it's going to be 1 plus 7 divided by 2 times H, which is 4H. So 4H is the area of that trapezoid. So the shaded area is basically EFAB minus that triangle. Well, let's just call that P, let's say. So it'll be APB. Yeah. So there'd be 4H minus 1/2 base times height. And the base is 7, and the height is H2. Okay, that's pretty decent, I think. But the only problem is we got a bunch of variables here. And we're going to have to use similar triangles. I think triangle APB is similar to triangle FPE, right? You can see that. They've got the same angles because this is parallel to that. So that means this angle will be the same as that angle. And then those are opposite angles, these guys right here. So those would be similar triangles. I'm pretty confident about that. So that means that H1 over H2 would be the same as EF over AB, which is EF 1 over 7. So that means that 7H1 is H2. And then the full H is H1 plus H2, right? So that's going to be H1 plus 7H1. So H is 8H1. And therefore, or you can write H is 8H2 over 7. That's another way, right? Yeah, H1. Yeah, and therefore, H2 would be equivalent to 7H over 8. All right. So I'll go back into there and substitute that in for it. So that'd be 4H minus 7 over 2 times 7H over 8. And that's going to be 4H minus 49H over 16. And that's 15H over 16. Now remember, there's 4 of these guys. There's 4 sides, right? So there's going to be 4 of them. So the total shaded area will be 4 times that. So that's 15H over 4. Okay, 15H over 4. Now, we'd be done, but we unfortunately have to figure out a numerical value. And so we got to figure out what H is. We have to figure out the value for H. So that's where this nice diagram will help us to figure out the numerical value of H. Now, it's the same diagram. It's just a little bit labeled a little bit differently, and I'll explain how. So this EF is still 1, AB is still 7, but since we're drawing lines that are going down from E to Q and F to R, this q to r is also 1. Now, a to b was 7, so that means this will be 3 and that will be 3, right? Because then ab becomes 7 because there's symmetry on either side. Okay, now the exact same thing on this side. When we do it, this would also be 3. The same kind of story. So that means if we were to draw the height, which basically is all the way down to t, they have told us previously that the height is 4. Remember that guy? They told you that. So this is 4 right here, and this guy is the same as this guy, so that's 3. And then anything else that we figured out? Oh no, this is h, this f to r. So then we can use Pythagoras on that triangle FTR. Triangle FTR, you can use Pythagoras. So 4 squared plus 3 squared is equal to 8 squared. And therefore h would be 5. And there we go, plug it into there finally. So 15 times 5 divided by 4. That looks to me like 75 over 4. And there we have the correct answer to a relatively challenging question. Determine all pairs xy of real numbers that satisfy the following system of inequalities. Let's start with this guy right here. Let's put everything on one side, and when we do, we need to, I guess, somehow manipulate this. Minus 8x squared minus 32xy is less than or equal to 0. And this, obviously we'd have to factor this, and I think x squared plus 4xy minus 4 squared, that would be x 4 plus 4xy squared. I'm just doing this to make sure. 2x squared 4xy plus 2x squared times minus 4 plus 2 4xy times minus 4, and I believe it does give the same result. Okay, that's good. Plus 16. You just have to rearrange the terms a little bit, but it would be the same thing. 32xy. Okay, so we got it. So that means that this is basically x squared plus 4xy minus 4 all squared is less than or equal to 0. Okay, now anything squared is going to be greater than 0, so we don't need to have it less than, I mean, that's pointless. So it's equal to 0. I think that's pretty much, because it's something squared, right? Something squared is always going to be greater than or equal to 0, so it's got to be equal to 0. So that's equation 1. And by this same process, we can factor that, and you get that it's y squared minus 8xy plus 5 all squared. Yeah, and you can verify that. So that's equation 2. So the first step in this question is to get these big challenging guys, this guy and this guy, factored into these. Well, they're not simple, but they look a little bit better. Now we can use our algebra to try to solve this if possible. So what I'm going to do is 5 times equation 1 plus 4 times equation 2. Oh, actually, before I do that, I'm going to take the square root of both sides. Get rid of those squares. Just have this like this and like that. Yeah. That's better, right? So we'll call this equation 1 and this equation 2. That's a little bit better. Okay, so now if I do 5 times equation 1 plus 4 times equation 2, it becomes 5x squared plus 20xy minus 20 plus 4y squared minus 32xy plus 20 is equal to 0. And therefore, This is 5x squared minus 12xy plus 4y squared is equal to 0. And therefore, this I think factors very nicely, 5x minus 2y and x minus 2y. And therefore, x is equal to either 2 over 5y or x is equal to 2y. Okay, I'm getting somewhere. If I take this guy and sub it into 1, this is equation 1, remember, I will get, let's see here, 4 over 25 y squared plus 8 over 5 y squared minus 4 is equal to 0. So 44 over 25 y squared is 4. Y squared therefore would be, 25 over 11. And therefore y would be plus or minus 5 over root 11. Yeah. And then, you substitute it back into 1 to get the value for x, and x would therefore be plus or minus 2 over root 11. In a very similar way, you take x equals 2y, sub it into any of those. You sub it into 1, let's say, this guy. And then you get 4y squared plus 8y squared minus 4 is 0. And therefore 12y squared is equal to 4. And therefore y squared is equal to 1/3. And then for y is equal to 1 plus or minus 1 over root 3. And then similarly, sub that back into the equation to get the value for x, and you get x equal to plus or minus 2 over root 3. So our pairs, xy, looks like, let's see here, 2 over root 11 with 5 over root 11. That's the first guy. The next one is minus 2 over root 11 and minus 5 over root 11. And then 2 over root 3, 1 over root 3, and then minus 2 over root 3, and minus 1 over root 3. So there we go. That completes the number 10 of all these individual problems.